Okay, now we get to talk about the periodic table of elements, okay? And so this is actually pretty cool, and it's actually very well organized. So I'm trying to figure out where to put me so that you can still see what's everything that's on the screen without looking at my nose hairs. Wait, I'm just kidding. Okay, so the periodic table, this organizes 118 different elements into groups with similar properties and places them in order of increasing atomic mass. So the learning goal for this video is to be able to use the periodic table to identify the group and the period of an element, as well as identify the element as a metal, a non-metal, or a metalloid. On the periodic table, the elements are arranged according to if they have similar properties or not. So the groups contain elements with similar properties in vertical columns, where periods are horizontal rows of elements, and they're counted from the top to the bottom and of the table as periods 1 through 7. So we can see here that we have groups, and then we have periods here. You can see that the blues are metals, the greens are metalloids, and then the yellows are non-metals. Okay, so that's how they are grouped, and it actually is pretty cool when you learn how to use the table. So the group numbers are written at the top of each of the vertical columns, and they use the letter A for representative elements. So groups 1A through 8A would be the representative elements, where the letter B is for transition elements, 3B to 12B. And an alternative system can assign the numbers 1 to 18 to all of the groups from left to the right across the periodic table. And because both systems are currently in use, they're both shown on the periodic table in the text and are included in our discussions of elements of the group numbers. So looking at these guys again, the group is going to be the columns, where the periods are going to be the rows. Okay, and so again, when you learn the groupings, it really starts to make sense. And so the alkali metals are all going to be in the 1A, right? Alkaline earth metals are going to be in 2A. The transition elements are in the middle. No common name elements are here, halogens and noble gases. If I were to learn any of the groups, I would probably know that alkali is here on the left, alkaline earth metals is next, and then over on the right are your halogens and your noble gases, because those are the ones that we really do talk about quite a bit, and it's important to kind of understand. If I say, oh, the noble gases, you can see, that they're the ones on the right, and they're the, unstable ones, etc. Group 1A are the alkali metals, and these include lithium, sodium, potassium, rubidium, and cesium. And you can see that these are some different pictures of them. Your halogens are going to be on the right-hand side, and this is group 7A, and these include chloride, bromide, and iodine. Okay, and so again, it's just kind of cool how they organized it. So our study check now is going to be to identify the element described in each of the following. Group 7A, period 4, BrClMn. So pause me for a second and let's see how you did. All right, so what we were trying to identify was bromine for this number 1. For 2 was magnesium, and for 3 it was nitrogen. Moving on to metals, nonmetals, and metalloids, the heavy zigzag line separates metals and nonmetals. So the metals are located to the left, nonmetals are located to the right, and metalloids are located along the heavy zigzag line between the metals and nonmetals. So again, you can see it's color-coded here. Your metals are on your left. Along the zigzags are going to be your metalloids, and on the right are going to be your nonmetals. Okay. So, there we are. So metals are shiny and ductile, and they're good conductors of heat and electricity. Nonmetals are dull, brittle, and they're poor conductors of heat and electricity, but they're good as insulators. And then metalloids are better conductors than nonmetals, but they're not as good as metals, and they can be used as semiconductors and insulators. Okay, so that just kind of tells you why we have the different groupings and what they might be useful for. So here is a fun table of some characteristics of the metal, metalloids, and nonmetals. Okay, so you can read that. And now we have another study check. So identify each of the following elements as metal, nonmetal, or metalloid. Okay, pause me and come back. All right, sodium is metal, chlorine is nonmetal, silicon would be metalloid, iron is metal, and carbon would be nonmetal. All right, here's another one. Select all of the elements that match the description. Pause me, and then come back. And what did we get? Okay, metals in group 4A would be SN and PB. Nonmetals in group 5A, N and P. Metalloids, Si and Ge. Okay, all right, and then linking this to health. Of all of the elements, 20 are essential for well-being and survival of the human body. 4 elements, which would be oxygen, carbon, hydrogen, and nitrogen. Put my little thumb in, right? So 4. These make up 96% of our body mass. So they're very, very important for us. Macro minerals are representative in elements, and they're utilized and important for formation of bones and teeth, maintenance of our heart and blood vessels, muscle contractions, right? Sodium, potassium, ATP, ACE pump you hear about, calcium, chlorine, right? Phosphorus, phosphate, right? Magnesium. So these are all going to be very important in muscle contractions, nerves, impulses, and acid-base balances of the body fluids, as well as regulation of cellular metabolism. And when we look at them, these are the major elements that are in the human body. Okay, they're in red. Okay, so fun little health check.